Okay, so well, this is, of course, naturally week 9. It kind of makes sense. Um, we just came back from this break. I hope everybody was able to get some rest. I know for myself, I was continuing getting settled into my apartment and taking care of stuff. I also worked on my conference paper. I'm up to 21 pages now, so I got 7 pages added to that during the break. Um, but now we're going to go and dive right into systems thinking proper. We had a brief introduction to it last week. Now we're going to get into the nitty gritty of it, so to say. Now remember, systems thinking is just a tool. It is a approach. There are other approaches. It's an approach that's useful. It's very beneficial. Organizations are looking for it. Forbes did discuss that in an article in May of this year. LinkedIn, indeed, they do list it as a soft skill that companies are looking for in their new candidates. So it's important that we understand what systems thinking is. And last week, we kind of took a look at where it comes from. It comes from systems theory. And systems theory is tied to complexity theory. It's tied to network theory, graph theory, nonlinear dynamical systems theory, also known as chaos theory, evolutionary biology, numerous different areas that have contributed to the development of systems theory and thus systems thinking. So, to briefly recap, we talked about systems thinking before the break, and we looked at Peter Senge, and he described the need to apply systems thinking. We do need to apply it as leaders. We have to be able to properly evaluate and analyze every element in the system. Now, remember, a system could be the team that you are a part of. It could be the organization. It could be, it goes all the way up to actually the universe. And on a, speaking cosmologically, of course, this isn't metaphorical. Everything is a part of a system. And it depends on what system you are looking at. You also have to consider not just the internal elements, but you have to consider what additional systems is it either a part of, is it subordinate to, or that it's connected to through uh, interactions, communication, that connection. Systems thinking is all about connection, the interconnectedness. So when we're looking at the elements, we do want to use analysis. We analyze the elements, whether they're people, policies, procedures, etc. We want to understand every detail we can about them. And then we step back, once again, metaphorically speaking, and we look at the whole system in a holistic manner. And their analysis will not work. So we use what's called synthesis. And we're looking at the interconnectedness between the various elements and interconnected systems. That is really what allows for a leader to be able to see the big picture. I'm sure you've heard that expression used many times. That is the big picture. When we step back and we want to know, how do all these employees, the policies, the procedures, the manufacturing processes, how do all these things fit together to make a coherent system? So we discussed about schemas. Now, if you remember, a schema, it's a concept from psychology, and it is how we basically store information into our mind. We use the mind as like the software. The computer is the brain. And so we're using the software to put the actual memories into the parts of the brain where it needs to go. And a schema allows for us to be able to recall things quickly. It helps us make sense of everything. And we use them every day, from going to the store to buy groceries, to house chores, to your schoolwork, everything. So schemas are essential. And they are definitely a part of this, because we are putting things into our mind about the elements. And then we're looking at the interconnectedness, and we're wanting to understand that. And so we've got to put that information someplace. Schemas we use these to construct mental models. A mental model helps us to be able to organize information and events so we can recall them at a later date and time. That is basically all they come out to be. It's a way that we make sense of the world around us. You will see this listed as sense making. That's the process of understanding what's around us. We engage in sense making. So there are parts to a system that we discussed, and we looked at 5 basic components. You have 2 or more elements. You're not going to have a system with just one element. It just doesn't work. You have an individual at that point. You need inflow. So you need information, products, you need issues, problems, requirements, something that's flowing in. And then you have the outflow. And the outflow is simply what that system is putting out into the customer base, the employee base, wherever that product, that service, that policy, whatever it's influencing, that's the outflow. You have stock and feedback loops. And if you'll bear with me 1 second, I should have, I love Zoom, but it really does get crazy when I'm trying to get to my files. There's the Zoom bar covers everything up at times. Let me find this real quick. It should be here because there's an actual stock and flow graph, and I don't know if you've ever seen them before, and I'd like for you to be able to see that to kind of get an idea. Give me 1 moment. Let me find where that's at. Might need to go back and just do a check through my whole system. Of course, the Zoom bar is in my way. There we go. STOCK. Let's try that. There we go. It's in my OneDrive. It's a strange place to keep it. Of course, it doesn't like that. Let me try 1 more file, and then after that, we are going to get rolling, and I'll have to upload it. It's a very, let me just try an online search. It's a very useful tool that leaders can employ to understand the inner workings of their system, of their organization. Stock and flow diagrams. Bingo. Now, images. That work. It's not what I wanted, but it will work. All right, let me share this with you real quick. This is a really simplified version of it, and I will upload one that's more specific to business management after the class. Stop this share, and let me share this one now. And stock and flow. Got it. Okay, so this, once again, is a very generic view of it. You see here that there's a stock that's, or I should say you have an inflow. That's like a faucet draining water into a basin. The basin holding the water is the stock. And then the outflow, that's the drain at the bottom that lets some of that stored up water, it lets it out. Okay, so in a business, your inflow, that's going to be resources, manpower, that's going to be knowledge, the knowledge base. Your stock, that is the internal processing of the raw materials using the man hours, the labor, and you develop your stock. And from the stock, now you disperse that out. If it's services, that is the outflow. If it's a product, then that's the outflow. And like I said, this is a real general version of this, and I will find my graph from grad school, and I will upload that later today as long as I can find it. So that is basically what a stock and flow is. Now let's go back to our PowerPoint slides. All right. And then, of course, you have feedback loops. And we are actually going to be discussing something called a causal loop diagram. And there you're going to learn about two types of feedback loops. You have a balancing feedback loop and a reinforcement feedback loop. And I will show you those in the causal loop diagram here in a little bit. It's in the slides, and we'll cover that. In a few weeks, you will be learning, or I should say, you will be able to develop causal loop diagrams yourself that actually portray the feedback loops. So remember, there's only two types in that particular system. And that's very important because a feedback loop can change a system from being in the positive to being in the negative real fast. And as a leader, we have to understand that so that we employ the right feedback loop at the right time. You have something called interdependent complexity. To effectively describe systems thinking as how interdependent complex things interact over time. This is what's still from last week. Over time is one of the key phrases that you're going to have to be working with for the next 8 weeks. It's not enough that you collect information about the elements. What is that information over time? That is the key thing when dealing with a system. You're not dealing with something that is static, meaning non-moving, sitting there just in a form of stasis. But this is vibrant. It's like a stream flowing through your backyard. As long as that stream is running, there is life. There are maybe little fishies, there's bugs, there's plant life. But if you put a dam and you make it so that there's no fresh water coming in, so you have a dam at each end, you're left with a pond, and that pond is going to become stagnant. And stagnation in the ecological systems leads to death. Well, the same thing is true in a system in the business world. If you get to a point of stagnation, your system can experience death. It will no longer be viable. Tufekci noted that systems thinking is how things interact with each other over time. I feel like I just said that, and I apparently put that in there twice. It is very important. I shouldn't have put it twice. However, it is extremely important. You've got to look at the interactions between the elements over a period of time. And typically, you're going to specify what that period of time is. You're not going to want to take the entire lifespan of the organization. You're going to look at maybe the third quarter. You're going to look at year 2024. You're going to put an upper and a lower limit to that time period. Now, there's other academic fields. Business management is just one of many. And business management does fall under, yes, business, but it does fall under sociology and even psychology. There's a lot of academic fields out there that don't always look at systems in this way. However, there is a move through academia to bring systems thinking into other fields of study, such as the biological sciences, the medical sciences, cosmology, astronomy. Systems thinking has helped these fields to be able to grow. Chemistry might not have brought it in as much as they will in the future, but I think there's a beginning, a movement, starting, bringing it in, ushering in the era of systems thinking into most fields. History, you don't see a lot of systems thinking in history. Yet, as you're going to see later in this course, you can use systems thinking to break down history and make it so that you can understand it in all of the details. We're going to be going through talking about Vlad Tepes III. That's the historical person that Dracula is based off of, which is appropriate because Halloween's coming up. And we won't get to it till next month, but still, it's in the fall. We're going to learn how we can use systems thinking to break down history. And I chose that event because instead of turning to IBM or something like that, I wanted something that was real general, real basic. I've used music. I've used music before in showing how systems theory is useful in understanding even songs and videos from artists. Once again, it's a tool. It's not the only tool, maybe it's not the best tool for the job at times, but it is a very powerful tool. And if you use it properly, there are rewards to be reaped. Meadows defined a system as a set of things, meaning people, cells, molecules, or whatever, interconnected in such a way that they produce their own pattern of behavior over time. So now we've taken that definition and we've extended it a little bit. We've gone a little deeper. Not only are we looking at the interconnection over time, but there's a pattern of behavior that's unique to this collection of elements. And remember, elements can also be called nodes. You may see it worded that way in literature. Meadows further states that a system is an interconnected state of elements that is coherently organized in a way that achieves something. And yes, I just saw my typo. I'll have to fix it later. I do apologize about that. There's a story why there's typos. When I was working on these slides, I was exercising, which is normal. But I've been doing a lot of intense walking, like an hour and a half each day, and at a real quick pace. I was working on some slides and I didn't realize I was turning the speed of my treadmill up. So it was getting faster and faster and faster, and I didn't know why. Next thing I knew, I was running. Now, I was impressed because I haven't been able to run physically because of my condition, my disability. I haven't been able to run in like 2 decades. And I was on the treadmill running, and I was like, this is good. So I did. I ran for 5 minutes before I put it back down to walking at my normal quick pace. And then I ran for another 5 minutes at the end, which shows that my MS really is going into remission. I'm really happy about that. I still have MS, but at least I'm getting to a point where I can exercise more fully now. So that was the good part. The bad part is I made a few mistakes in the slides during this event, so I apologize. So the next stage of this development of this definition is that the system is interconnected. It's an interconnected set of elements that is coherently organized in a way that achieves something. So not only is it over time, but it must have its own pattern of behavior over time, and it must achieve something over time. So behavior, achieving something, this system is moving like a creek in the backyard. It's flowing. It's not in a moment of stasis. It's not standing still. It's progressing. Meadows gave 3 components to a system. You have elements, interconnectedness, and a function or purpose. And these make up the 3 elements according to Meadows. And elements are the easiest to identify. You can look at a system and you can identify individuals, human beings, as elements. You can look at the SOP and you can see the policies as elements. You can look at procedures. You can look at products, processes. They're all elements. They're easy to identify. Now, interconnectedness, that's what binds or ties all these various elements together. So in our class, we are each elements. What interconnects us is the discussion boards. It's the assignments, the communication, the emails, the interactivity between us. That is that interconnectedness in the system that is our class. Now, the function or purpose of a system can be the most difficult to identify. In our class, if we see that as a system, and it is, our function or purpose is really education. You are taking this class to gain education, but you're also taking this class to get credit points. You get some credits because you need them to graduate. You might be taking this class solely because it's on your degree plan. Well, in the process, I hope that you do succeed and get your credits. I hope that you gain information. So there's 3 different purposes that this class has. Which one is the purpose? Or perhaps it's a combination of all 3 together that make the actual purpose. Any change to the function or purpose of a system alters that system in an existential way. If we change the purpose of our class, that system is no longer one working towards education. Because whether it's credits, a degree plan, or knowledge, it's all kind of under education. So maybe the purpose of our class is just education, non-specified education. But let's change that. Let's take it and say, instead of being a class where you're getting knowledge, we're making widgets. Now we've changed that system in its very existence, its very form, its reason for being. It's ontologically changed. It no longer is a system based on education. It is a system based on manufacturing widgets. So any change to that function or purpose will totally change the system. Systems interconnect with each other. Meadows pointed out that a system is often found to be connected to or a part of other systems. And I believe last week I used the example of our solar system. Here's the Earth and Moon in the solar system. They are part of the system that is our solar system. Each of the planets, each of the moons are elements. But that's not the end of it. Our solar system is in the Milky Way galaxy. And the galaxy is a system of elements of all these solar systems, planets and black holes, quasars, all in this one system. But that's not the end of it. Because we step back a little further, the solar system is part of the galaxy. The galaxy is part of a cluster of galaxies in our local group, as they call it. Back out further, and we're part of the universe. So systems often belong to other systems. Systems thinking allows for unique solutions to complex issues. Our class is a system, but we are part of, we fall under several degree plans, which are systems. We fall under academics at the school, which is a department, but it's a system. And academics falls under Cleary University. Cleary University falls under the educational system in general of higher education. It's one of many colleges. So you have to define the parameters of the system you are working with in that evaluation. So that ends our review. On to some new material. This was an article by Peters, published in 2014. Peters examined how systems thinking can be applied to healthcare. That article looked at systems thinking in healthcare. He noted that systems thinking can assist us in seeing the various components of a system. How can you identify the elements, the interconnectedness, the function or purpose if we don't apply systems thinking? We really can't, because you can only think of a system in terms of thinking of it as a system. I know this sounds real basic, but that's literally what it is. You can't come in using design thinking to identify a system, its interconnectedness, and the elements. You can't use other approaches. You've got to use something that deals with a system. An organization is made up of departments, which is made up of teams. These are all systems that are interconnected. Whether you're in an organization that's siloed or whether you're in an organization that is cross-functional matrix. Peters discussed mental models, which we've discussed a bit, and how we can use them, which he calls explicit models. I was hoping I said a little bit more explicit models there because he does go a little bit more into it. I hope it's on one of the other slides here soon. Peters stated systems thinking is intended to improve the quality of those perceptions of the whole, its parts, and the interactions within and between levels. I have a graphic that will be coming up here in a few slides where I took a TV show from the 70s and 80s called MASH. And I took one episode, and it's a Korean War comedy, and it's about during the Korean War. It's a medical unit, and I broke it down into a systems graph. Well, once again, I did not apply design thinking. I used systems thinking because I was looking at a system of characters acting, interrelated, interconnected, working towards a function or purpose. So systems thinking did indeed help me to understand the whole, to understand the parts and the interactions. Each time we interpret a system, we use a model, okay? We create a model. Now, there are archetypes, and archetypes are models that we see occurring normally. We can take an archetype and we can superimpose it next or right on top of our system, and we can see which archetype best relates to our system. And that helps us to be able to predict things or predict potential outcomes within that system. But you got to use the right archetype. Not every archetype is going to match every system. And if I'm not mistaken, archetypes may be in next week's material, but I wanted to give you a little teaser into that because archetypes really is that model, that mental model that we are using in understanding systems. A mental model, that is an easy way to understand a topic. It gives us a quick understanding of what that system should generally be like. Now it's up to us, the ones who are doing the systems thinking, to go in and find the specifics out about the elements and the interconnectedness, the function and the purpose. But generally, the archetype does give us a blueprint. Here we go, explicit versus implicit models. Peter suggested using explicit models. Now, implicit, that refers to something that is implied or it's suggested without bias. But explicit, that refers to something that is clearly stated or fully explained. So when we are dealing with a system model, we want something that is detailed, explained. We want to understand as much as we can. That's why when we're looking at the elements, we use analytical approaches. We look for every variable, every factor, everything we can account for. Then when we step back, we use synthesis and look at how the elements relate to one another. All these elements are in a form of relationship with the other elements. Now, that's easy to think of when we're talking about human beings being the elements, but what about a policy or a procedure? Can that be in a form of a relationship with other policies? Absolutely. In our own university, we have the late policy. So when you're submitting your assignments late, you have a policy, you know what it is, the professors know what it is, we use it. But that policy also relates to other policies, such as grading policies. So those two right there share a relationship because it deals with the students, their work, the professor, they're grading the work. One deals with how we grade, the other one deals with the timeliness of the submission of what's going to be graded. So yes, there is a relationship. So Peter says use explicit models. Make sure that all the details are fully explained. Ontology of systems thinking. Ontology has to deal with the existence of something. Peters pointed out that systems thinking results from numerous theories that were used to develop the concept of systems thinking. It's not a standalone concept. It relies upon, well, I told you I numbered them a minute ago. Without nonlinear dynamical systems theory, systems theory wouldn't exist. Without complexity theory, systems thinking wouldn't make sense. So systems thinking is a multidisciplinary concept. It requires theories from multiple disciplines to be at work. You have sociology, psychology, physics, you have mathematics, you have set theory, graph theory, network theory, even cybernetics comes into play. Peters noted that systems thinking is under more, it's under more encompassing theories such as general systems theory, which was developed by Ludwig von Bertalanffy. I can't get Lanffy. Anyway, Ludwig von, he did the seminal work. He did the beginning, the very foundational research into what's known as general systems theory. And general systems theory, it's one of those theories that it was used in developing systems theory and thus systems thinking. Think of it like this. Systems theory is just that. It's a theory. It is literally a scientific theory, meaning it's been evaluated, understood, explained. It's been peer-reviewed, tested for decades and decades. So we know that it's good and true because it's gone through the scientific method. Systems thinking is an application of that theory. So while you are learning a little bit about the theory, it's more important that you know how to apply this in a practical way. Systems archetypes help to understand general patterns, including positive and negative feedback loops. Like I said, you can take a systems archetype, and I want to say there's like, I think there's 7 archetypes. And you can take that and you can put it onto what you're looking at with you. Okay, so you write down your system, you understand your system, you get as much information as you can, you take the system's archetype, you kind of overlay it, metaphorically speaking, and you see how the interconnections would look if it followed that system's archetype, like a blueprint. Now you know you're dealing with this kind of system. So you, as the leader, know that you have to make this kind of decision. You have to implement it this kind of way. You have to wait this kind of period of time before something emerges. And then you get what you were after, and that is an innovative, creative policy, procedure, perception, whatever it is you're working towards. So foundational theories here. Peters listed several theories, methods, and tools under the systems theory umbrella. Now, sometimes I shift between saying systems thinking to systems theory. Like I said, systems thinking is systems theory in a practical application. And for me, I use both terms, and for me, they're fairly synonymous. For you, systems thinking probably is the one that will work best for you because you're not going into the theoretical aspects as much as, well, if you go to grad school, you will, but you're not there right now. So you really need to learn how to apply the concepts of this. It's like learning geometry, but you're learning how to use it versus just all the theorems and everything like that. So we have here catastrophe theory. We're going to go through a number of the theories that are used in systems thinking. Catastrophe theory is used in mathematics and geometry to understand how small changes create vastly different outcomes in a system. Now, I want to point you out to something because I want you to pay attention. Small changes create vastly different outcomes. This is a common thread that you're going to see through the rest of this lecture. You may be familiar with the general idea of chaos theory about a butterfly flapping its wings causes a hurricane on the other side of the planet. That's what we're talking about. Small changes over time. Sometimes as a leader, in order to get the outcome that we need for our organization or our team, it doesn't take major change. Sometimes it takes just small little alterations. And then you let time take its course. And these wonderful, rather large outcomes begin to emerge. That's systems thinking applied. That's catastrophe theory in action. Cybernetics, historically used as a synonym for systems theory. Thankfully, we've gotten away from that a bit because now we do have a field of cybernetics and we have systems theory, and they've kind of come apart from each other. They really aren't synonyms anymore. At one point, they were. It is a field of study of the communication and control of regulatory feedback in both living and non-living systems, which in essence is what we're doing when we're applying systems thinking, is we're looking at that interaction. Interaction usually involves some sort of relationship or communicative event. Now let's look at one of my favorite theories, nonlinear dynamical systems theory, also called chaos theory. used in mathematics and also in physics to understand how subtle changes can create different outcomes. Here it is again. We're seeing this change starts small, grows big. We're looking at that motif. That's what we're looking at. In an organization, when you are in leadership, you're going to notice sometimes it's the small changes that have the largest outcomes. So foundational theories. So foundational theories, what these are like the seminal research, the theories that started it all. You have general systems theory, and this helps to isolate a general theory to understand systems better. General systems theory can be used in research of all kinds. We turn back to it because it's a good starting point. You have learning organizations theory, and that's by Peter Senge. And this is used to understand how organizational learning can radically transform the organization. Organizational learning, it's not that everybody grabs a book and opens it up. Organizational learning is that an organization as an entity begins to learn. Remember, organizations are set up, they're structured in a way that mimics the human being. The human being, we have minds. We have a spinal cord, that's our central nervous system. That is like the senior leadership in the C-suite. You have nerves coming from your spine and your brainstem that go out through your body. This is like middle management, because what the senior leaders have, those at the bottom can't get unless there's a conduit. That's middle management. And the needs that the operation, the frontline workers have, the leaders don't even know about it unless there's a conduit that brings it to them, much like the peripheral nerves. And then you've got the frontline supervisors. You have the managers. They're like the ends of the peripheral nerves. There is a sensor, a nervous sensor there. That's what they're like. And then the team is like the cells that make up the liver. And another department would be the lungs. And there's a different type of cells there with a different specialization. Everything relates together. Organizations mimic the human body. Legally, organizations are seen to have a status as an entity. They're taxed. They have legal rights. In essence, they're almost a person. Not quite, but they're almost. So they can learn. An organization can learn from past mistakes. An organization can learn how to approach things in a better way. It takes every component in that organization to do it, though. You need the cells, all the employees. You need all levels of leadership, the nervous system, to work towards this learning about a new process, a new stimuli that's affecting that organization. Now there's path dependency theories. These use evolutionary biology to understand how periods of stasis are bifurcated with intense change. We can actually graph out an organization going through its regular routine, coming to a point of bifurcation. That means it splits. That's a moment of chaos. And in the graph, it's almost like this, looks almost like a heartbeat, going up and down. Just the line just goes up and down, up and down, up and down. And then it splits off into two directions. That's a bifurcation. That's a chaotic event. That is change. In an organization, that's the moment of change. We can turn to the past and grab a hold of the status quo like Clark talked about and go back to the way we've always done it before. Or we can challenge the status quo, accept the chaos that is the moment of change, and allow something new, something creative, something innovative to emerge. The leadership may not have been able to really know that was what was going to happen. If you let the process play out, you get sometimes a policy, a product, an idea, something that is so innovative, so revolutionary, it changes the world, kind of like the iPhone. So we have to understand these moments of bifurcation. Now, without going too deep into it, the ratio between moments of chaos, bifurcation, change, that ratio is consistent. It's always 4.6692 something. And I have to look it up because I don't have it memorized like I used to. And I can't even memorize the whole thing. It's literally infinitely long. But whether it's an organization going through periods of chaos, change, and innovation, whether it's dripping water from your faucet, whether it's radiation and magnetic impulses from a pulsar light years away, that ratio is always the same. It's called a universal constant. Not the universal constant, but a universal constant. So we as leaders, we can use that information to know when our team or our organization is due for another moment of chaos and change. It helps us to be able to plan for these. So yes, path dependency theories were essential in developing systems thinking. Returning to foundational theories, or still continuing with foundational theories, you have agent-based modeling, ABM. And this is a virtual representation of a complex system. There is software. There are programs online. There are apps that you can use to conduct modeling. You can use it when you're evaluating your organization. You have to understand the elements, the interconnectedness, and you begin to model what that's going to look like in the moment, what it looked like in the past, and what it can look like in the future. There's network analysis, and that is social network analysis technically. And that's where computer science is used to examine network theory and how it affects social entities. You are a social entity. Cleary University as an organization is a social entity. We can use network theory, graph theory, network analysis in understanding how all the students and faculty and staff members at Cleary University interact together to form that organization, that system. Now there's scenario planning. Scenario planning may not sound like a theory, but well, it is. And it looks at potential future events or outcomes. So it's similar to modeling, where you figure out where you are at the moment, where you have been, as far as elements and interconnectedness, and based on track records, based on available data, you can generally predict a spectrum between the most possible, the least possible, the most beneficial, the least beneficial of outcomes. As a leader, you must do this so that you can prepare yourself and your team for the worst case scenario. But yet you work for and you strive for the best case scenario. In the military, in the Army particularly, we had a saying, we pray for peace, but we prepare for war. That's the concept. This way, as a leader, you are not caught unaware. Systems dynamical modeling. This evaluates behaviors within systems over time. If you decide that, hey, systems thinking and systems theory is a wonderful thing and you want to dive into it further, you go to grad school, you want to take in one of the hardest classes I've ever had, and that was a class in complexity. It's really difficult, but very, very beneficial. You use things like systems dynamical modeling to understand the inner workings of that system over what? Over time, within a block period of time. And by understanding that, you understand the relationships, you can understand behaviors, you can understand the reasoning for different decisions. You can get to the point you can predict with a fair amount of certainty future outcomes. And I say that because we can never account for every single variable affecting a system at any given moment. So, knowing that, a good leader does not say, I know this is going to happen. They say, more than likely, this is going to happen. if all considered stays the same, this should be the outcome. It may sound wishy-washy, but it isn't, because we truly cannot predict the future, but we can narrow it down to the most probable range where the future may lie. There's tools, and Peters lists these following tools that are associated with systems thinking. Causal loop diagrams, CLDs. You are going to be learning about these. They're a wonderful tool. And these are a quantitative evaluation of how feedback loops impact mental models. Innovation. This lies under change management. This looks at the history of a system or organization and considers emergent situations. Emergent situations, that goes back to evolutionary biology. Okay, so you have a bird. It has brown feathers and a short beak. It gets stuck on a ship, travels thousands of miles. And we'll have to say for this case, there's two birds, a male and a female. They get off at this island. There are no birds like them on that island. They get there and they begin to reproduce. Unfortunately, the insects in the island are just a little bit further into the tree than they're used to. So, over a couple generations, their beaks begin to get longer to meet that need. The predators see their brown colors because all the rocks are white. So the bird stands out. So over a few generations, white feathers begin to appear. And it's not like the birds consciously make their beaks grow, and they don't consciously change the colors of their feathers. There are birth defects in the birds. And the birds that have these defects with a longer beak and white feathers, they are not eaten by the predators. So they get to reproduce. So those now defective genes become the primary genes of that species on the island. Small trip through emergence. The beak growing and the feathers changing are emergent attributes. The same thing happens in an organization. When you look at it as a system, you begin to see different organizational behaviors that weren't in an organization before now have somehow emerged in that organization. Hopefully, they're beneficial. Sometimes they're detrimental. As a leader, you've got to be able to try to figure out which one it is. And if it's detrimental, how do we change it to something positive? That's why you've got to consider change management. You got to consider how to kind of best control the emergence that occurs through this chaotic shift through bifurcations, creativity, innovation, a new policy procedure, or whatever emerging. Continuing with the tools, you have participatory impact pathway analysis, PIPA. These are workshops, and these aid in applying stakeholder engagement within a system. Stakeholder theory is very, very useful for organizations. One, you have your external stakeholders, you have your investors, and you have your customers. But there's more than that. You have your supply chain for raw resources. You have your shipping for your products that you complete. You finished up making the widgets. Now you got to send them to your customers. You have people inside the organization that sell the product to the consumers, sales. Now, inside the organization, you also have stakeholders, internal stakeholders. They're the employees, the leaders, the janitors, the engineers, the administrative individuals, human resource department. All these stakeholders have got to be understood. You need to have high engagement with your stakeholders in the system, both internally and externally. Well, these workshops help in testing new things and saying, will this work with our stakeholders? The stakeholders of IBM may be by far different than the stakeholders of Netflix. Yet many people that use IBM probably watch Netflix. But the needs that they have for that product are different. You don't expect your calculator to entertain you, and you don't expect your entertainment to do mathematical computations. So you need to run things through these simulations, through these workshops, so you know, am I applying the right action, the right stressor, the right force at this moment in the system to get what we want. Now we have process mapping. This is used to show a sequence of actions and responses. I almost wore my drinks, but I'm glad I did it. In leadership, you have to be able to engage in decision making. Part of this is understanding the ramifications of the decision you are making. What are the short-term, mid-term, and long-term consequences? Are they positive or are they negative? So you have to kind of map this out. You got to see what the sequence of actions is going to be. If I do this and I do this, will I get this? Now that's linear thinking. You can use linear thinking when you're dealing with just the element. But when you step back to the holistic view of the system, now we're not using cause and effect. We're saying there's a multitude of variables. I need to figure out as many of them as I can. And since I'm one person, I can't do that. So I bring a team together. I say, class, we are now a team. We are working to figure out all the variables that impact this situation. Bonnie may find some that Adam doesn't. Savannah may find some that I never even considered. But together as a group, we are able to find quite a few of them. Not all of them. We can never find all of them. So we as leaders and as team members, we have to understand this. And we accept that although we put all the work into this decision and we implement this decision, we still have to evaluate it after we implement it because there's still variables we can't account for. And it could cause things to go awry, which means we have to fix that. So we have to always evaluate the decisions we make. Another tool are stock and flow diagrams. And I promise you, I will get you one that's more specific to business to kind of describe it to you. On the top left corner of the page, you have your inputs, and that's your resources, that's man hours, that's customer orders, all that stuff. They're coming in. Investors. In the middle, you have the organization doing the work. And on the bottom right corner, you have an arrow going out. That is your products, your services. That's waste, chemical waste, air pollution. That's food products for distribution and consuming. That's anything that comes out of the organization. You need to account for everything coming in, everything done inside, and everything that's sent out. This ties into corporate social responsibility because now you got to consider the environment, the humans that live in that environment. Is there waste going out there? Are the products safe? So there's a lot of factors to consider. And a stock and flow diagram definitely helps. It's a quantitative instrument used to show how a system functions. And it can be used in developing a model-based analysis. I once did a 33-page consultancy report for one of my graduate level classes. I had to include a stock and flow diagram in there, along with a decision matrix, along with a million other things. Because in order to decide what an organization should do, you have to understand everything you can about that organization and account for every little detail that you can. And of course, admit that you can't find them all and try to account for that. Does it sound complex? Yes, and it is. But it's really, for me, it's fun. It's exciting. I don't know if you can tell, but I'm energized by this topic. I love this topic. We turn now to the article by Goodman, published in 2016. Move Zoom. There we go. Different individuals may attach different meanings to systems thinking. Yes, I saw that typo. I apologize. So what systems thinking means for, let's just say, the CEO of IBM. may be a little different than what it means for the CEO of Uber. Is one of them right? Is one of them wrong? Well, I'm going to venture to say that they're both right. And in some ways, they both may be wrong. That's because you got to take systems thinking and it needs to be applied to the system you are evaluating. You can't evaluate IBM the same way you would Uber. So it is essential to clearly define terms at the start of a discussion, talk, presentation, or even applying a tool like systems thinking. If you've ever been involved in a debate, when a new term is brought up, you need to include a definition so that all parties in that debate can use that definition, and the definition needs to be agreed upon. So if we're talking and we're saying, we're going to talk about divergent thinking, just something like that. Thinking in a divergent way, divergent thinking. Some people might instantly think about ADD, ADHD, that there's a divergence in thought process there, and they're right. Some might think, and we need to find new, creative, innovative ways of viewing things, and they're right. Some may think of something else, but you need to come up with a definition that's going to be used during the usage of that word. Systems thinking is more than just a list of tools or applications. It literally is a philosophical approach, and it's also a diagnostic tool. You can use systems thinking to figure out what is broken in that system. Where is it falling apart? So what is underneath a system? Is there a support structure? What's there? Goodman stated, systems thinking often involves moving from observing events or data to identifying patterns of behavior over time, to surfacing the underlying structures that drive those events and patterns. If you've ever had organizational behavior, another class that I have the privilege of teaching, behavior is driven by other factors. We have got motivation, intrinsic and extrinsic motivation that drives behavior. We have got ambition. We've got goals. We've got the way we process decisions. We've got our attitudes, our self-awareness, our perception, our personality, our identity. All these things come into play, and it does alter behavior. So with systems thinking, we're observing a system. We're observing all the factors of the elements and everything that we can, but we're looking for these behavioral patterns over time. And we want to dig down one layer lower and find out why these behaviors are there. System thinking allows for us to ask better questions instead of just jumping to conclusions. Instead of just shooting from the cuff and hoping it sticks to the wall. Have you ever done that? Try to come up with an idea and you're just basically throwing things on a wall almost, hoping something sticks. While that has to be done at times, it's not very effective. But being able to know what question to ask really helps you find the right answer. What was it? Was it The Hitchhiker's Guide to the Galaxy when they go before the big computer, or that they go before the elders, those children that were like millions and millions of years old, and they built this computer to find the answer to all of life's questions. And they said, no, you need to come up with you need to know what the question is. And ultimately the answer was 42, basically meaning it's arbitrary. We have to have the correct question. Everyone involved must be willing to see the entirety of a situation, of a system, of an organization. So if you're working with a team that is diving into systems thinking, every person on that team needs to be dedicated to literally seeing the whole big picture. It's okay to pull the microscope out in a metaphorical sense and to analyze each element. That's what we're supposed to do. But then put that microscope up and look at the big picture. Look at how everything relates together. Kind of like, well, I don't know, in space, you got the moon and the earth, but there's gravity between them. We can't see gravity, but we see its effects. The same thing happens in a system. We see this behavior over time, like the sun, the moon, earth, all caught in gravity with each other, and they react and they act in a specific way. But we don't see that gravity is underlying that behavior. But you have to dig through it, and you can find it. You can find what lies under that system. Goodman pointed out that systems thinking can help us solve problems while teaching us that there are no perfect solutions and that each decision we make will affect other components of the system. So we're on a team. We're engaged in systems thinking. We've identified and analyzed the elements. We've looked at the interconnectivity, and we change one thing in that system. It could literally change the entire system. Because if we change how two elements are interconnected, it could literally change the quote unquote gravity in that system and make things go all awry. So there's a responsibility on leadership to make sure that they've analyzed and evaluated and synthesized everything appropriately so the changes they implement are not going to cause havoc. But beyond that, they need to evaluate after that change has been implemented, they need to evaluate what happens next. If everything starts getting better, great. If it starts getting worse, you got to go back to the drawing board and kind of start all over again. So systems thinking can help us analyze different paths that we could take and their potential results. When we understand the components in a system, the elements, and how they interrelate, we can then theoretically change parts of it and play it out in like a simulation over time and understand what the effect is going to be. So there are some reasons to use systems thinking. One is that the issue is actually important. The second reason is that the problem is chronic. It's not a one-time event. You're not going to use systems thinking if you have one occurrence of an event. But if it occurs all the time, over a period of time, it's regularly happening, systems thinking could be the answer. Another reason is that the problem is very familiar and has a known history. So if you're dealing with the psychology in organizational behavior or the sociology inside of an organization, we've studied that enough that we can say that it's familiar. We can say that it has a known history. So systems thinking would work. Lastly, people have unsuccessfully tried to solve the problem before. If you as a leader receive a problem to deal with, and many leaders before you have tried to work on it and they couldn't get it figured out, it's time to use systems thinking. Just like Clark pointed out, no blame. We don't need to be blaming others. That is counterproductive, and it is also counterproductive in systems thinking. Individuals must share information concerning the problem because only some people have the same information. Let's take our class. Some people in this class may understand the situation better than others. But if we share the information, now everybody has access to that knowledge. That knowledge sharing has now elevated that team to being more productive. This can help you clarify the causal loops, because you may see in there that there is a feedback loop and you can't identify where it's at. Well, getting more people to give you input, feedback, that can help you identify where that feedback loop lies. And each person also needs to share their mental models. And I don't know how many times I accidentally typed mental moodles. That's a weird word, moodle. But anyway, you got to share the mental models. What are you using to understand this? How are you retaining that information? How do you break it down? Share that with the team. Let that knowledge be shared because now you are elevating your team to being a learning team, much like a learning organization. A learning organization learns kind of like a person does. A learning team learns the same way, but it's much smaller. Okay, the big moment you've been waiting for. Causal loop diagrams. So it's a diagram that uses loops to explain a cause. That's all that means. A diagram using loops that explains a cause. Goodman presented causal loop diagrams as an important tool. I agree. They break the story up into its constituent components. How can you understand what a story is unless you understand who all the actors in there are? What are the elements? What people are involved? What policies? What procedures? The diagram must include all variables. Now, like I said, you're going to miss some, but let's not miss the obvious ones. If you have an organization with 150 people and you're doing a study on that group using systems thinking, you need to account for all 150 people. If they have 262 policies, they need to be accounted for. The unknowns, those are the things that are going to elude you, and you need to get more people trying to identify them. You want to keep the diagram simple. Well, yes, because they get complex really fast. So when you start learning how to do these diagrams, you basically start with two circles, and you basically have a path arrow that shows it goes this way, wraps up, and then comes around the other side like a figure 8, or it might be just one circle. It depends how it's designed. You have your feedback loops. You got the people. You have the actions or the situations. You add more people. You add more policies, more situations, more feedback loops. This thing gets crazy fast. Include internal and external variables that you can control. While you have to account for the variables you can't control, you're not going to be able to do anything about them. So yes, you account for them. They're there. You know about them, but you're focused on what you can actually change. What's in your power to change? And lastly, the loop does not need to be right. Instead, it must properly represent the problem or story being analyzed. Think back to a situation in your past. I'm sure you could detail out how that situation occurred. You could give a time frame to it. You could talk about various incidents. Although that situation may be incorrect, it may not be ethical. It might have caused problems. It might have been the wrong decision. That's okay. You're just analyzing what occurred. It's like a detective. You're not looking for right or wrong. You're just looking for what happened. That's what you're doing. You have to figure out what occurred, who was involved, when did it happen, and you put it down into the diagram. That is a very simplified causal loop diagram. This shows how total quality management training leads to total quality management activities occurring, that then a perceived threat rises up, and suddenly there's resistance to that threat. It cycles back around to the activities, and then you have a need for more training. And so this is a very simple diagram. It shows the place of training, total quality management training, in relationship to the total quality management activities, in the presence of a perceived threat, and resistance in the middle management. We just took a simplified, what we put here in a simplified diagram, what could be a very complex situation in an organization. This is also a causal loop diagram. That is one that I did for the TV show MASH for one episode, and I forget which one it was. But in here, you have got all the different individuals. You have the type of interaction that they have, which is demonstrated by the type of line and the color of the line. You have loops, feedback loops occurring in here. If you notice, you see up the top right, you see an upside down triangle, and then you see a square with rounded corners off to the far right. Well, between those two, you see two red arrows. That is a feedback loop. You see another feedback loop occurring at the bottom. You see there's a blue square at the bottom, and right in the middle, there's another blue square, and there's two green arrows coming to and from those two. That's another feedback loop. Now, a balancing feedback loop will take a negative issue and add something positive to it, bringing it back to being neutral. A reinforcement feedback loop will take something that is negative and add another negative to it, making it even more negative. So every time you cycle through that loop in that diagram, the situation gets more and more negative. Now you could use a reinforcement loop to make something positive by adding a positive in that loop. So every time you go through that loop in the diagram, you become more positive. You might think that that's positive, that's a beneficial thing. Sometimes too much positivity in a system will destroy it. We need a balance between the two. Normally, you want to try to bring that system kind of back to equilibrium, kind of to that zero moment. So yes, a negative occurs, a positive occurs, but you want things to balance back out, because if not, human psychology, we get anxious, we get depressed. If it's too negative, we get depressed and anxious. If it's too positive, we become overly optimistic and we don't perceive threats on the horizon. So we have to use those feedback loops as essential tools in these diagrams. Now, for the purpose of what you're doing in this class, you're not going to be using that loop to do anything. All you're doing is demonstrating what is occurring. So if you have got, let's say, 4 people, and they're involved in this system, you can graph it out using a causal loop diagram. But between 2 of the people, there's a feedback loop. One person is always totally optimistic, no matter what it is. Well, that would be a reinforcement feedback loop, which is good at times, bad at others. Once again, all you're doing is you're depicting what is occurring in the system. Archetypes. Never try to force an archetype onto a problem or situation. You're going to have an assignment coming up in this class, in this course, where you're going to be learning a lot about archetypes. And it's going to make a lot more sense then. But an archetype is a template that you can use to better understand a system. These templates can help you to get a general understanding of a problem in that system or a situation in that system. The group that's evaluating the issue must use the archetypes as they become apparent to the group. You can't walk in and say, we are just going to go ahead and use this archetype today. No, the group has got to see how that archetype literally already exists in that system. Then you go and you pull the archetype out, that blueprint, and you can understand your system better. And once again, this is going to make more sense when you get to the assignment dealing with archetypes. But when you get there, remember, archetypes are like a blueprint, not for creating something, but for understanding something. Goodman recommended using causal loop diagrams when applying systems thinking to a problem or situation. Totally agree with that. My last relationship I had was catastrophic. I decided to apply a causal loop diagram, and it made sense of things for me. It showed me where the problems laid. They laid inside me and inside of her. And I was able to deal with the problems inside of me. I couldn't change the ones in her, but I could change the ones in me. So that's what I focused on, what I could change. That concludes today's lecture. This is a very in-depth lecture because the material is in-depth. I want to open the floor up for questions, and I encourage you, I implore you, feel free to ask me questions today, please.
I just had a quick question because it was a while ago when we were talking about specific systems. Um, the complex adaptive system, that is something that we're discussing in class, right?
Basically, yeah, along with other types of systems, yeah, everything from a real generalized system to a complex adaptive, yeah.
Okay, thanks.
You can use this for, and you're going to see this when you get there's a handout that's coming to you in the modules here in the next week or two, I think, about archetypes. When you get that, or when you go to that module and open it up, this is going to make a lot more sense because you're going to see that, yes, there may be 7 or 5, I think it's 7 general types of archetypes, which means there's basically 7 general system types. That's generalization there. In the real world, every system has its own nuances. So every system is indeed special, unique, but we can get a good understanding using that template. Anybody have any questions? Anything else? For me personally, when I was in my class on complexity, learning about systems theory, systems thinking, about systems, it was an eye opener. And I had tried, I don't even try to, it happened automatically. I began employing systems thinking in my daily life. It helped me make sense of things around me that before I couldn't really understand. It may have taken me a lot longer using a multitude of psychological theories or sociological theories to be able to kind of understand. But when I put systems thinking into there, it made more sense to me quickly, more quickly. And then when I turned to all these theories, then I was able to get even a deeper understanding and everything was more clearer to me. For me, it was like a new pair of glasses. You may or may not have that experience. And it's fine. Either way is fine. You're unique. But this information is useful. Organizations are looking for this. It is a soft skill. And so by learning it, it gives you an advantage getting out into the workforce. If there's no other questions, we will go ahead and be done. As always, if you do have any questions, please email me. And we will have class back on campus and, of course, on Zoom Monday. And then next Wednesday will be all on Zoom again. So we're going to be back to our normal schedule. All right, class is dismissed.
Thank you so much for your time. Have a great day.
Oh, you're most welcome. You have a good day, Peter.